Excited. How is everybody doing this morning? I see that I had my sound off. Anyways, good afternoon, everybody, or good evening for those of you who are in other parts of the world. I am so glad to see you all, and I'm ready for office hour number 12 for Unit 1. Unit 1, Data Science, World Quant University. If you're tuning in for the first time, my name is Nicholas. I am a data scientist, and I can't wait to talk to everybody today about their Unit 1 questions. So I already see a lot of familiar faces here in the chat room. I see Yahia is here, Mustafa is here, Gerald, Andrea, Ahau is here. Rabina is back. Second office hour in one day. Why not? Tiger is here. Good evening to you, Tiger. And Bishoy is also here. So hello, hello, hello. So glad to see everyone. So I see Christian is here, Tatiana, or excuse me, Tatanka. Godwin is here. Usha is also here. So good to see you all. So I'm going to pull up my whiteboard, and I am so curious to hear what people are interested in working on today. I know we'll definitely work on the PW mini project, so we can definitely do that. What else do people want to do? Babatunde is asking me how I've been doing. I've been doing great. I've been doing lots of interesting work today, so I really am excited to take all that positive energy and bring it into office hours. Joebo is here. So wonderful. I just love how people kind of roll into class and we're all ready to go. Tiger wants to know my path to being a data scientist. I can definitely talk about that at the end. With data cleaning, Babatunde, I'm going to leave that until we get to the part of the course where we look at pandas and NumPy, because data cleaning has a lot to do with pandas and NumPy. So again, and actually that'll go also for Yahia's question. Well, actually, Yahia's question is a little bit different, but we can definitely talk about importing files. And I know that we also wanted to talk about JSON files as well. So I can put those two together. Okay, I feel like we have more than enough to do today. So what I am going to do is I'm going to go to the data wrangling folder, and then I'll go to mini projects, and I will go to the PW mini project and open it up. And remember, this mini project is going to be all about using basic uh, Python data structures, defining functions, and all sorts of things like that. So I will see what I can do. I see that there's some other questions coming in, so I will do my best to get to all of them. I may not be able to do them all today, so just hold on, and I promise we'll get to them all at least by the end of the class, but definitely next week. So I'm here on the PW mini project, and the first thing I'm going to do is I'm going to run the first two cells. Remember, it's always important to import the grader. Otherwise, we can't grade your mini projects. And then I'm going to scroll down, and the first thing I'm going to do is I'm going to just download the data. And all of this data comes from the British National Health Service. So if we have any UK citizens in the audience, we'll be talking about your health service. And once that data is completed, I'm going to import two packages, gzip and one called simple JSON. And actually, what we're going to see here is two instances where we import files into Python. So let's go over these. So the first is I have gzip.open. So with gzip.open, and this whole first line, we're going to call this establishing a context. That is to say, a context of an open file in which we are going to do a bunch of things. In this case, it happens to be a zipped file, so I need to use the gzip package here. But what I'll do is I'll say with gzip open, and then I will add the file path, or the path to the file. And there are a few things that I want to point out. I'm going to go back to Jupyter. I'm going to go back to the File Navigator. And I want to show everyone that the data that we want is in this folder, PW Data. And if I click in PW Data, here are the two files that I'm interested in. And so the way that I can access this data, given that the file that I'm running right now, the PW notebook, is in the same directory as the PW data folder, what I can do is I can write it this way, where I have PW data as the folder, and then a slash, and then the name of the file that I'm interested in. And after that, I have a comma and then a string with two things in it, an R and a B. And the R and the B have specific meanings when you're opening a file. The R means read. So what I'm saying is you'll have read access to this file so you can read what's in it. And B, I can't remember if B stands for binary or bytes. But what I'm saying is this isn't a simple text file. This is saved in binary, so you're going to need to decode it. So that's what's happening in this first line. And then you can see that my line ends. Bishoy is saying it's binary. Okay, well, good. And somebody's asking why this file name starts with 2017-01. That's when we first downloaded the data. That's when we created this data set. But it has no significance. And then the last part is I have as F, which means when I use in the following indented block, when I use F, I'm saying, when I say F, I am referring to this file. And so in the next block where it's indented here, I have one line of code. And what I'm doing is I'm using the simple JSON package, which I've imported with an alias called JSON. And I'm saying, use the JSON package to load this file. So look at it and parse it and turn it into a JSON object for me and save that as scripts. And then the next thing I'll do is I will look at I'll do the same thing, but with a different data set. I'll have the scripts data set, which I'm saving as scripts, and then I'll have the practices data set, which I'm saving as practices. Now, just to give everyone an idea of what we're dealing with here, if I look at the type for script, oh wait, I haven't run this cell, so it won't run first. All right, so we're letting it churn here. It's churning. It's picking up that information. It's turning it into JSON objects. And once it's run, I can look at the type, the data type of scripts, and I can see that it's a list. And if I look at the length of the list, I can see that I have 382,726 items. What do you guys think are the items in this list? Babatunde says they're dictionaries. Tiger says they're binary numbers. Rabina says they're columns. Kingsley says they're dictionaries. Let's see here. Let's just take a look. I'll look at the first two items. So I'll do :2, and I can see that there are 1, 2 items, and they are dictionaries. In fact, if I look at just one of them, and I see the type here, it tells me that they're dictionaries. And all of this is a way of helping us understand that JSON files, when it comes to interacting with them in Python, tend to be, well, no, they are dictionaries. And we can think of, if we're thinking about this in terms of columns and rows, we can think of each dictionary as a record, as one row. And each one of these keys, I guess, could be the column. So if we were thinking about it in terms of some sort of data table, that's how we might think about it. But in this case, we're dealing with JSON or dictionaries. So we'll put that aside for now and not worry about that. Okay, questions up to this point? Rabina says everything is okay. So let's move on. Here's a glossary of terms, not for the, well, for some of the important I see a lot of great questions here, so let me answer them. So in this case, Tatanka wants to know, how do we fetch a JSON file that's in an API? The answer to that question is a little bit outside the scope of this course, so I'm not going to get into it. But if I were fetching something from a website, I might use a package like the requests library, which I will put here into the chat. And what the requests dictionary allows me to do is it allows me to go out to the internet and pull down a JSON file or pull down any file. And from there, once I got that file, it would come to me as text, and I would use json.loads to load it into a JSON file. And someone's also mentioning beautiful soup. That's also an option. It's a slightly different use case, but it's the same thing. Now, let's see here. Yahi is asking, why do we use JSON here? And the reason why is JSON, having your records as a list of dictionaries, that is to say a JSON file like this, it's extremely portable. So it's easy to send as text from one user to another or send it across the internet. You don't need to worry about all of these different key values matching in every single dictionary. Some of them can have practice, for instance, some of them can be missing practice. And so it's a very robust way of storing and transporting information. And then Ekamini has a question, which is, does this mean that a JSON file can't be a list? Well, that requires, there are a couple answers to that question. The first is we can see that our scripts object here is a list of dictionaries. So one way of thinking of a JSON file is as a list of dictionaries. Okay, so we've looked at scripts, and also just for good measure, let's also look at practices. So here what we have is all the information for a given doctor's office. And in the scripts, we have all the information for a given prescription that a doctor would write for a patient. And here we have what, 380 something thousand entries. So there really is no limit for the size of a JSON file. The only limit is how much can you fit in RAM, or how much can you fit on your hard drive, or how much can you fit, once you go above that, in your distributed computer network. All right. So we've looked at practices and we've looked at scripts. And the first thing that we need to do is we need to create some summary statistics. Some summary statistics. Now, here we have several things that we need to create. We need to create the sum, the mean, the standard deviation, the first quartile, the median, and the third quartile. So let's, and this would be for a given key value pair in either of the data sets. So let's think about this for a second. Let's look at scripts again, and we'll just look at the first entry. And let's say that I'm interested in the number of items prescribed here, the number of items prescribed. How would I go through my entire list and get all the values associated with the items key in all of the different records here? And I see Yehaya is asking, should we define it? Let's see here. Will we find a built-in function that can do the summary statistics, or should we define it? Well, there are tools that do exist, but for the purposes of this assignment, we're going to figure out how to do it ourselves. So let's start small. Let's say I'm going to take just I'll take my first scripts here, and I'll call it a test case. And what would I do if I wanted to get just this value here, the 2? And I see Kingsley has a good answer there. I want to work up to it though first. So let's not get there just yet. So how do I, if I have a dictionary, how do I get a value? All right, so Kingsley has an idea here. So I would do something like test case and then index. Excuse me, not index, items. All right, that's possible. And now that I know that I can get this from one of them, how can I get from all of them? So let's change our test case. And instead of having just one script, I'll have a list of five, a list of five. So how can I go through each of these and get the 2 here, get the 1 here, get the 12 here, get the 3 here, and so on and so forth? What would be some good strategies? And I see Charles doing some sort of list notation. Remember that with a dictionary, we don't, we use the key value pair. So a lot of people are saying I could use a for loop. So I could say for script in test case, and let's just say print script items. Okay, I have all of these, so I can definitely do it in a for loop, but I think there's a more efficient way. And I think Otumba has a really good idea. And by the way, everyone, Otumba just got married, so we should all congratulate him. Okay, so I'm going to do a list comprehension instead. So here, I'm going to have for script in test case, and then I'll say script items. And we can see here that now I have all the items in the list. So now that I have a list of all the items, how do I get the total value? How do I sum these all together? It's so exciting to see all of these congratulations. Kingsley, you are right again. You've been right all along. And now we finally worked our way up to, we've worked our way up to what Kingsley originally put in the chat. So I have my list comprehension, which will go through all of the dictionaries in the scripts list of dictionaries. And then it'll go through each of those dictionaries and pull out the items value. And then once it has all 300,000 of those, it will sum them all together to one number. So for example, if I wanted to see what the sum of all of those items was across all of the scripts, I would do that. And this just shows you how fast Python is, that we went through over 300,000 of these in like a nanosecond. The total is 4.4 million. 4.4 million. So let's begin putting this all together. Let's begin thinking about how we can put this all together. I want to create a function. Actually, let's think about it this way. Let's put it here in the describe function. So what if I had values, and what I did was I copied and pasted our previous code here, and instead of items, specifying items, I had it as the key here, the key. And so every time I ran describe, it would create a list with all the values for a given key. And then instead of doing the sum all around that list comprehension, I could just do sum values. Let's see how that would work. So I see Yahia has come up with a question. They say, so in JSON, it doesn't treat each like a variable. Yahia, I don't quite understand your question. Can you rephrase it? So here I have describe, and this time I'll do items. And indeed, I get the correct answer here. Okay, so we've done that. We've done that. My next question is, how do we get the average, or also called the mean? How would I find the mean in this case? So Kingsley says divide the total by the length of the values, and that's what a lot of people are also saying. Okay, that seems pretty doable. So basically it would be the sum of the values divided by the length of the values. Let's see what that looks like. Okay, that seems to be working. Excellent. Boy, we're really doing good here. All right, so we're doing good. And then how can I find the standard deviation? How can I find the standard deviation? What is standard deviation? Is this a term that people have heard before? I see Yahia has, Bishoy has. I see Babatunde has a whole thing going on here. Okay, great. So let's look and see what we have for our options. And I'm going to go to Python math module. There we go, mathematical functions. And I will copy and paste it here into the chat. And I'm going to look up some of the functions we have available to us in this standard library. I don't see anything about standard deviation. So it looks like we're going to have to do it ourselves. So actually, I wonder if I can do this in, let's see here, Python, standard, deviation. I can't use NumPy, that would be cheating. So I won't do that. But it looks like I can use the standard deviation. I can use the statistics library, like one of you suggested. Babatunde did. So let's use that. So let's go here, and I'll say from statistics, import, what did they call it? stdev, stdev. And here I'll just put stdev values. So let's see what that looks like. Whoops. Hold on. I'm in the wrong window here for a second. Okay, it looks like we're good. Babatunde thinks this is cheating also. Okay, we can do it another way. Let's do it a less cheating way. So I'll do, we can use what Babatunde said. So we could take the from math import square root, and why don't we, my goodness, I'm looking at all of the different code proposals that people have put into the chat. So I'll just take Wait, let's see here. Which one here? We need a square root here somewhere. A square root, element in list. I'm going to do it a little bit differently here. I'm going to create a helper function. So I'll call this STD for standard deviation, and let's say it'll take in the values. Or why not? Why don't we also do, let's see here. So I'm going to do it just, Yahia says, believe me, I'm a statistician. Good, Yahia, I believe you 100%. So we can do this. And we can put it in here. All right. So Yahia, if this is the standard deviation, what is arg? Oh, average, huh? Let's see if this works. Will this work? Because we're raising the sum of values minus the average. Hold on. Because the sum of the values is a list, and the average, let's run it. Let's see what happens. Oops. So first there's some sort of error. Hold on. I will remove this. Okay. And now I have a type error because I'm trying to use a list and a float here. A list and a float. All right. I'm gonna do Andrea's. I'll do Andrea's answer. Here we go. And I'll swap out values for item list. So we have, okay, the element minus the average squared for element in values. Let's see if that works. N is not defined. Hold on, where is N? Oh, length of values should be N. And here I have a 0. That doesn't make sense. Now, Leby's saying we could use NumPy, but we can't use NumPy. That would be cheating. We're not allowed to use NumPy. Yahia says maybe it's values minus 1. Let's see. Oh, wait, this should be, I don't think so. Honestly, I'm getting a little confused with this code. What I would like to do is just split it out and use a separate function here. So let's take what Andrea has done and let's just unpack it a little bit. All right. So the first thing I'm going to do is I'm going to go here, second moment would be, I'm going to start with the values. So it'll be the value squared for value in values. And then I want the sum of that Okay. And then I'll divide it by the length of the values. Oh, you're right, Andrea. You're absolutely right. I'm looking at the wrong thing. You are correct. Let me finish this formula. You're absolutely right. All credit goes to Andrea on this one. And then I will do first moment. I'm just going to divide your code up into two different, just in a few more lines. And then I'll say return square root second moment minus first moment squared. Okay, I think that should be it. I'm going to just copy this out here, and let's try a bunch of different things. So I'll call this S1. I'll call mine S2. So note here, the reason that I'm doing this is note how I can call a function from inside another function. And then I'll do S3, which will be our check, and those will be values. And then let's just look at S1, S2, and S3. And let's see if they all match. Whoop, name error. Name mean is not defined. Oh, excuse me. This needs to be, let me think about this. Mean values. I will just copy and paste this here. There we go. Okay, good. Well, we pretty much all got the same answers, give or take a little bit. So let's just say that everyone here is right. There are lots of ways to put this into code. And let's just leave it at that. Yahi is right, Andrea is right, the statistics package is right. We're all right. So I'm going to just, for the sake of brevity, I'll just do it this way. I'll keep it simple. Okay. Excellent. All right. Now, let's take our, so I think that this is, I think we can do one more, looking at what we have to do. So the next thing that we need to do is we need to do our quantiles. So I need the 25th quantile, the 75th quantile, and here the median is actually the 50th quantile. So it would be really helpful if I could create a function called quantile. And what I'll do is I'll give Q for the quantile, and then it'll also take the values. I like the way you're thinking, Andrea. My goodness, all sorts of great ideas here. Now, Babatunde has one idea, and let's take a look at it. What Babatunde is doing is saying A will equal the length of the data times whatever our Q is here. So the length of values times the, well, no, hold on. I can't put this as an integer. That wouldn't work. Andrea has an idea of using round. We could use round. Let's see how round works. Q times, excuse me, length of values. And then I would return, I'll call this ID, IDX for index. And then I'll say return values IDX. Excuse me, this should not be, this should be values square brackets IDX. Okay. And Yaya makes a really good point. What I need to do is I need to sort this list first. So I'll put sorted and then IDX. So let's take a look here and see what we get. I'll do quantile, Guantanamera, Guajira, Guantanamera. I'll do quantile 0.25. I'll do quantile 0.25 here, and then I'll do quantile 0.5 and quantile 0.75. Let's see what happens. All right, let's look at our summary here. Okay. Looks like we're pretty good. So here I have round. I did remove those square brackets. And here I have the sorted values. Okay, I think we're good to go. So let's run this through our grader and see what we get. Everyone keep your fingers crossed. Hey, 1.0. Good work. Excellent job. Excellent, excellent, excellent. Well, thank you so much. Thank you, Babatunde, Andrea, Kingsley, everyone, Yahia, especially for your help. And thank you, everyone, for catching all of my errors. This was super helpful for me. Great. Okay, beautiful. So let's see here. We have about 10 minutes left, and we've talked about the PW mini project. We can move on to questions two and the rest of them in a future session. We talked about importing files and JSON at the beginning of the class as part of talking about the mini project. And so maybe we can spend a few minutes talking about the data science path. What do you guys think? All right. So let me talk to you guys a little bit about my path. I don't know how standard my path is, but maybe there are some lessons we can pull out from my story that'll be helpful to you guys. And feel free to ask me questions as I go. All right. But let me talk about my path. So my path is I did a PhD. I did a PhD in Spanish and Portuguese. And actually, more specifically, it was in Latin American literature. So I started in by analyzing novels and learning foreign languages, or what for me were foreign languages. So, like studying Romance languages and studying Latin America, focusing mostly on Mexico. So, that's what I did my PhD on. And for several years after I finished my PhD, I worked as a Spanish professor. So, teaching Spanish language to American students and also teaching them Spanish, like from Spain, but mostly Latin American literature. And after I did that, I actually got another professor job where I was teaching translation studies. So I moved from literature to translation. Oops. So I spent a lot of time talking about translation, talking about different ideologies behind translation, teaching students how to do research projects in translation. And Andrea is right, it's not exactly data science. But there's an interesting thing about translation, which is there's one side of translation studies that's very much about the humanities. However, there's another side of translation studies which is very similar to linguistics. More specifically, like corpus linguistics. And so what happened is even though I started in the humanities, when I moved to translation studies, I found myself being more interested in the technical or quantitative side of the field. And so when I started learning more about that field, I said to myself, well, what can I do to learn a little bit more and to work in this space? And that's when I started teaching myself R, which is a programming language, and also Python. And I basically spent a little time learning R and then a lot of time learning Python because right then was when people were talking about oh, data science and how cool it is and how you can do all sorts of cool natural language processing things with it. And Robina is asking, is R short for Ruby? And R is not short for Ruby. R is its own programming language, which is used for statistics. And I think maybe Yahia can tell us more about it. But for example, I'll put a link here in the chat for R Studio if you're interested in learning more about R. And so I think I started learning Python in around 2016, 2017. And from there, when I left my professor job in translation studies, I was working in assessment. And I was helping language programs at a university evaluate their programs, evaluate their curricula. And you can think of assessment in um, higher education as very close to analytics in the private sector. So we can say that I was almost doing analytics. You can almost think of me as being a data analyst, but just specifically for language. And what I did is at that point, I was like, I think I want to be a data scientist full time. I want to leave university world. And so what I did was, while I was working as uh, an assessment person and doing analytics, what I would do is I would only take on projects that would help me about um, learn more about using Python and using data science and getting better with my statistics because I hadn't taken statistics since like my undergraduate, getting better with my math, getting better with my programming. And from there, I applied to a boot camp for data scientists. And there was like an application process and an exam to get in. And that was the data incubator. And from the data incubator, they asked me to become an instructor. So that's how I became a data scientist. So that's how I ended up teaching these courses to you guys. So that's my path. And I guess if I had to take a few lessons from it, I would say the following. One, you don't need to learn R in order to do data science. Either get really good at R or really good at Python. And I think it's better to stick with Python. The second thing is if you want to move into a new area, a really good idea is to find projects in your current area that can serve as a practice or as a portfolio for your new area. So I used my job in assessment as an excuse to do data science projects. And then the last thing, which I would point out, is if you want to be a data scientist, don't be scared about taking a job that's close to data science or uh, data science adjacent. And that way you can transition. And then the last thing I would say is what I'm not talking about here during this whole time, during this whole period in here, I was also doing job interviews to be a data scientist. And the interviews were going very badly because there was a lot I didn't know yet. But what I did is every time I had a bad interview, I would take the questions that they asked me, the things I didn't know, and then I would go home and study them. And so that way, when I went on to the next interview, I would know that answer. And there would be another one I didn't know, and I would have to study that. And so by looking through the different job descriptions and going into interviews, I was able to get better and better. And for me, the big step was when I was able to do like an intensive course, like the boot camp that I did, or even a course like this one. So that's my story. And I want to thank you guys for asking me about it and for letting me share it. And I hope that there are some lessons in there for you. But I see some people saying, Tatanka is saying lifelong learner, and I think that's the most important thing. The most important thing above all is to think of yourself as a lifelong learner. That is to say, it doesn't matter whether you're an undergrad, you're doing your PhD, or you're out in the world working. um, what you need to do is you need to always be learning new stuff and always growing sort of intellectually and emotionally. So those are the kind of the lessons that I would pull out there. So thank you guys for letting me share it. People are saying this is inspiring. I have to be honest, you guys are really inspiring to me because we're here every day. I know it's late at night where you are, and you're working really hard to get this done. So I really appreciate you guys coming here, answering questions that I give you, working on these projects with me. It's really, really wonderful. So, thank you guys so much for listening to my story. I can't wait to hear more about your stories in the following weeks. For now, though, I hope everyone has a wonderful, wonderful weekend. And until we meet again on Monday, happy, happy, happy data science all. Take care, guys. Bye bye.